Hey guys, it's Andy here. This is the John cell, a crystal cell composition developed by the YouTuber John from Manahawkin1. Link in the description of his video explaining it. These are my recorded outputs every 24 hours over a 7-day period. After 5 days, the output dropped about 97 and 87%. But we're still outputting more current than any other composition I've ever tried. I've never had a crystal cell stay above 500 microamps after 1 week. The only part that cannot be reused is the crystal composition. The magnesium core corrodes a fair bit, so eventually it will be unusable. John has found promising results with lead plates and magnesium. Link to that video in the description as well. I'll test that next week, hopefully. Alright, right now I'm going to take apart these two cells right here, the 1 centimeter and the 2 centimeter, and we're just going to see how much the magnesium has corroded. An interesting thing about John's composition, you can see it turns a lime green, which is very strange. At first I thought it was because of the nickel and copper combining with the materials, but this cell here doesn't even have nickel in it, so I've taken apart the two cells, and it's hard to see here, but there is almost no corrosion or oxidization of the copper pipe. There is a great deal of corrosion on the magnesium core. This thing was almost completely brand new. There was just a tiny bit of corrosion on it before, and now it's almost eaten right through. The nickel took a bit of a beating too. It's very brittle now, and it's changed color. It's kind of a dirty brown or rust color. This core here was corroded beforehand. I recycled it. So you can see there was heavy corrosion on it, which would explain why it had such high current output. This copper pipe has absolutely no blacking on it on the inside. I know it's hard to see, but it looks almost brand new inside other than all the scrapes and stuff. And I've used this one in different crystal cells as well. It's a lot of corrosion, but at the same time, it's the output was very impressive. Now, I got this big sucker here, so it's a 3/4 inch diameter instead of a 1/4, so we got a lot more to chew through. I imagine I'll get much better results with this. This here is brass, 70% copper, 30% zinc, and I'm getting pretty good results with it. I've scratched it up a bit to give myself some good contact points for testing, so I'm going to try this next. I did build one this big, like very tiny. This is a 1/4 inch height pipe, and I was getting some pretty good results off of it. I think I was getting 40 milliamps off of this with the 3/4 inch diameter magnesium core. So it's looking very promising considering I'm gonna have something this small output 40 milliamps. I also tried this guy, and I believe I got 200 milliamps off this one, 2 centimeters in height. If I can get 200 milliamps out of this guy and 40 milliamps out of this guy, 100 all the way down to 10 milliamps after a week, and this guy went all the way down to 1 milliamp and then 700 microamps. So it's very promising despite the fact that this magnesium eats right through. John said that he was going to try and find a replacement for magnesium, so if he finds that, I mean, I think that's a ticket. I put a tablespoon of baking soda in with distilled water, and I used that to oxidize magnesium. So I'm just following what John suggested to do, but trying my own little method. All the black is oxidization, so I left it in for about half an hour. The chemical reaction between baking soda, distilled water, and magnesium puts out 1 volt and somewhere around 4.5 milliamps with this size of magnesium. With a bigger piece of magnesium, you get more current output. It bubbles and fizzes a bit after a while in the baking soda, and that's the chemical reaction occurring. It has a silvery color before it goes in, so it's really easy to tell if you have enough oxidization on it, which is nice. The nickel corrodes quite a bit in these cells as well, so I'll have to test out probably the same method, just throwing it into the baking soda water. Maybe that'll protect it as well, but I want to focus on the magnesium as it has a very high rate of corrosion. So we'll see how that goes in the next few days, and I'll make another video and show my results. You can see a little bit of fizzing going on. So I hope you liked this video. Subscribe if you want to see more, and thanks for watching. Have a good day.